Here we have a pre-calculus problem. Okay, let's go to the question. Compute log base 9 of 27 negative log base 27 of 9. That is, we have to evaluate the value of this expression. Okay, to evaluate the value of this logarithmic expression, let me consider an important property in logarithm, that is log base m to the nth power of a. Okay, here in this logarithm, the argument is a and the base is a power, that is m to the nth power. Whenever the base of a logarithm is a power, now what we can do is we can move this exponent in front of the logarithm. When this exponent n is moved in front of the logarithm, it will become its reciprocal. That is, we have to get reciprocal for this exponent n over here. The reciprocal of n is 1 over n times log base m of a. So this is a property I am going to use to evaluate the value of this expression. Okay, in this given expression, log and the base of the first logarithm is 9. Actually, it is a power of 3, so it can be written as 3 to the second power, 27 negative log, and here it is 27 is a power of 3, it can be written as 3 to the third power of 9. Okay, here now we can move this exponent 2 in front of the logarithm, it will become its reciprocal, then we get 1 over 2 times log 27 to the base 3 negative. The same thing, we can move this exponent 3 in front of the logarithm, then this 3 will become its reciprocal, that is 1/3 times log base 3 of 9. Okay, here 1 over 2 times log base 3. This 27 is a power of 3, so we can write this 27 as 3 to the third power negative 1 over 3 times log base 3. This 9 is a power of 3, it can be written as 3 to the second power. Okay, now we can use the power rule of logarithm. That is, let's consider a log base a m to the nth power. Okay, here the argument is a power. Whenever the argument of logarithm is a power, we can move this exponent n in front of the logarithm. It will be multiplied by the logarithm. Then the result is n times log base a of m. Okay, here using this power rule of logarithm over here, we can move this exponent. That is, here the argument is a power, and we can move the exponent in the argument in front of the logarithm, and it will be multiplied by the logarithm. Then we get 1 over 2 times 3 times log base 3 of 3. So the same thing, here argument is a power, the exponent we have in the argument can be moved in front of the logarithm, and it is multiplied by the logarithm, negative 1/3 times 2 log base 3 of 3. Okay, we know that in any logarithm, if the argument and base are equal, then the value of that logarithm is just 1. Then we get to 1 over 2 times 3 times 1, negative 1 over 3 times 2 times, same here, that is 1. Okay, here we can multiply the fraction, this integer 3 and 1. So for that we have to multiply the numerator 1, the 3 over here and 1. So 1 times 3 is 3, 3 times 1 is 3, that is we get 3 over 2, negative 1 times 2 is 2, 2 times 1 is 2, 2 over 3. Okay, now we have to simplify, that is we have to do subtraction between the two fractions. Okay, whenever I want to do subtraction between the two fractions, I need to be getting the same denominator for both the fractions. Okay, here the denominator is 2 and here the denominator is 3. So to get the same denominator for both the fractions, we have to find the least common multiple of the two denominators. The least common multiple of 2 and 3 is 6. That is, we have to make each denominator as 6, which is a multiple of, which is the least common multiple of this 2 and 3. Okay, to make this denominator as 6, let's multiply both numerator and denominator of this fraction by 3. That is 3 times 3 divided by 2 times 3, negative. To make this denominator as 6, we have to multiply both numerator and denominator by 2. 2 times 2 divided by 3 times 2. Here 3 times 3 is 9 and 2 times 3 is 6, and negative 2 times 3 is 4, 3 times 2 is 6. Okay, now I got the same denominator for both the fractions, that is 6. Now we can take this 6 as a common denominator. Then we have to subtract the numerators, that is 9 negative 4. 9 negative 4 is 5, that is I am getting 5 over 6. Therefore, the value of the given logarithmic expression is 5 over 6.